Some of you will recognize this great piece of art. It is a neural network, and in this radar we have a look at some nice applications like Intel on how a computer can smell. We have Dominic Binks from Audio Analytics on sound analysis. Scott Miller from Dragon Innovation will tell us everything about the future of producing in China. And we have and Aha to close it all off. Welcome to the IoT Radar. Is it possible to smell without your nose? Yes, you can if you let a neuromorphic computer mimic your brain's neural network. Now, that is a mouthful for me. When Intel launched the Lohi neuromorphic computer chip in 2017, it promised to accelerate artificial intelligence. This Lohi chip is now used as an artificial nose. It is a self-learning chip. Well, self-learning. With the help of Intel's neuromorphic computer group and the Cornell University, the chip is capable to differentiate 10 different scents. How does it work? When we smell, our brain receives electric pulses from cells in our nose. The brain then classifies and recognizes all the signals and can tell what we smell. The Lohi is doing exactly the same. The chip includes digital circuits that mimic the brain's basic mechanics, and with the right set of algorithms it can classify different scents and can help detecting them. It is clear this application can be very useful in situations we don't want to stick our nose in. In this IoT radar we learned that computers can smell with help of neuromorphic chips, but computers can also hear. I have a meeting with Dominic Binks. He is Vice President Technology with Audio Analytic, a Cambridge company, and he can explain how a computer can hear and analyze sound. Good morning, Dominic.
Good morning.
Thank you for your time. We will discuss how computers can hear but also can understand.
The key points in terms of making a computer understand what it's hearing is, can you extract from the recorded audio key elements that are consistent with certain sounds? For example, perhaps a very easy one to think about is something like a smoke alarm. It has a very distinct pitch, tends to be quite cyclical, so there's a nice sort of quite easy way of understanding that's what you're looking for. You're looking for something in the range of, say, 2.4 kilohertz to 3 kilohertz that repeats every so often, and that's a sort of fairly straightforward sound to sort of look for. Sound itself gives you an understanding of the sound environment, and different sound environments may actually be the same physical location. Really good example would be something like a departure gate at an airport, where if it's quiet, the sound will be very, very different than once the departure gate fills up and there's lots of people there and talking. So Alexandria is essentially sort of two things. It's a data set in terms of a large volume of data, but it's also, we discovered through our years of working this, I mean, I've been with the company for 6.5 years, and it pre-existed me, that actually just managing that audio data is in itself a major challenge. Particularly when you go around the cycle of say retraining a model that you've trained before, maybe you've got some more data. How do you assess whether it's actually better compared to the previous model you had, which was perhaps trained with a different set of data, tested with a different set of data?
What can you say about the typical hardware requirement to do this sort of analysis?
We run on quite a lot of different things. Generally speaking, we don't need an awful lot in terms of specific hardware support. We're quite low in terms of both RAM, ROM, bits. But normally we would consider, ARM core level and above, from the M0 plus upwards, really.
Yeah. Now ARM recently introduced new M series architectures, the M55, also in combination with the U55. Which promises a huge performance boost. Is that something which can help you with your analysis, or what sort of new applications would that open up?
We've actually been loaned a board by ARM to play with the M55. The U55 they weren't able to lend to us, but the M55 they have. It offers a great boost for us. So on the Cortex A class, where quite frequently you've got neon, we've been able to use that, and it's just it's a really simple way of boosting performance dramatically. We see that same boost now on the M class, which is great. It just means that the models can do approximately about 4 times the amount of calculations in the same number of clock cycles. So it's a big win in terms of what we can do.
With the whole world disrupted by the coronavirus, there are some real questions about the future of producing in China. Scott Miller from Dragon Innovation is advising companies on how to produce their products, and with him I have a discussion on the current situation. Hi Scott, good to see you.
Oh, great to see you. Looking forward to our conversation.
Yeah, we're going to discuss producing in China. What, in your opinion, is the current situation?
Yeah, so we've got a team of about 15 dragons based in southern China, so the Pearl River Delta area, Shenzhen, Dongguan. And in talking with them, which we do on a pretty much a daily basis, we're seeing about 90% of the factories back online again, which is great news because everything was shut down for quite a while. Now, we are still seeing a fair amount of disruption in terms of the supply chain. So all the different sub-vendors that are supplying the factory doing final assembly and test, they may or may not be delayed. But it does seem like things are rebounding and getting back to normal, at least within China.
That doesn't mean we can expect a lot of these products already yet in Europe or in the US. We have to wait perhaps some time, or?
Yeah, the cycles that we typically see outside of any external disruption are typically companies are going to see their highest revenue sales from the day after US Thanksgiving through Christmas, and want to make sure that they've got the product in market by that point. So if we back that out, it means that often the engineering phase ought to be finishing up by the previous December. And then we jump into the factory selection, MPI process tooling, and then running pilots. So I think because of the previous delays, everybody's schedule is going to be pressurized. And maybe where we're going to see one of the bigger impacts is this coming Christmas. Just companies that haven't been able to produce the products they want. The good news is there's still time.
I can imagine a lot of companies are a bit reluctant to say, okay, we've seen now what the impact can be. Is it still a good idea to outsource your production to China, or should we look for local solutions?
Yeah, we've always been huge fans of building locally if possible. Building products is just insanely complex. It's orders of magnitude harder than most people would think. So being able to talk in the same time zone, same language, have a similar culture, just make things easier. Where it gets trickier is as you build in higher volumes, you may need different capabilities than exist locally, or price could become a factor, especially things that require a lot of manual assembly. So that might be reasons to think about factories that aren't in your own backyard. But we always say, start with what's around you. And then if those aren't viable solutions, then, look beyond that. Yeah, so I think China, for consumer electronics at least, which is my world, is going to remain very strong. They're truly the world's workshop. They have phenomenal domain knowledge. They've got a great labor force, wonderful roads and shipping to get the product in and out. But what I think is going to happen is the rest of the world is going to try to creep up to their capability as opposed to China's capability diminishing. So in a sense, it's almost like a rising tide lifts all boats. So I think there's, with this current challenge, a lot of opportunity for local factories to improve their game.